Hello, everybody. So I'm gonna give you an introduction a little bit about the problems that we're having at DBS Bank and how we are migrating from RDBMS to Spark. I'm going to give you an introduction, and then Chandra will continue and give you a more in-depth site with much more detail about the solution. So first, a couple of words of introduction. I'm Matteo, and I'm the head of data engineering at DBS Bank. And Chandra is a principal engineer at DBS Bank, and we work in the same team, actually. I don't know how many of you know DBS, probably not many, but it's the development bank of the government of Singapore. So it's basically the National Bank of Singapore. It's the largest bank in Southeast Asia with 400 billion in total assets, and has been DBS is going through a lot of innovation and transformation, and DBS has won in 2019 the award for being the best digital bank in the world. As I was saying, DBS is going through a complete transformation, and among the transformation there is this migration from a traditional RDBMS system to this big data world, actually. So migrating entire applications that are currently hosted in RDBMS to Hadoop and Spark specifically. The whole idea is that everything should be available to the users of the bank in a self-service model. So basically, each user can consume the services very much like what you would do in using AWS services. So I want to start by giving you a more detail with the problem statement and how we address this problem. So as I was saying, DBS is going through this transformation. We have multiple applications that are based on legacy SQL, legacy RDBMS, with specific SQL syntaxes and SQL construct and functions. So it's often not straightforward to migrate this application onto Spark. The other problem that we have is that we have a lot of BAs, business analysts, and ETL developers who know SQL very well because they have been using it for 25 years, but they have no knowledge at all of new technologies like Spark, big data, etc., etc. So our question is, how do we allow this developer to start using Spark, actually, without having them to write Java or Scala code, without having them to teach them all the development and deployment process, etc., etc. So we start with the assumption that SQL is the golden language here, because we have so many people and we have so much expertise in that. So we want to leverage that as much as we can. So we said, okay, what are these people? What do they need actually in order to get productive in this? So first of all is access to tools. So most of these people are used to tools like Oracle Studio, Teradata Studio, and they don't have an equivalent environment on top of Spark. So building a Spark pipeline is not as simple as writing some SQL, which is a store procedure and storing it, and it's done. They don't know anything about CI/CD pipelines, because you don't use CI/CD pipelines when you write SQL statement and when you write store procedure. So you have to get them up to speed with CI/CD. So we said, how can we address this? How can we make it easy for them to have a CI/CD environment? How can we make it easy to migrate application as seamless as possible? So how can we allow the migration of existing SQL, which is sometimes custom SQL, Teradata specific SQL, Exadata specific SQL, to SparkSQL? A lot of our jobs are metadata driven, actually. So a lot of the definition of the job about, for example, the type of files, the transformations that we do are metadata driven. So we have to replicate a similar behavior. The other thing that we need to provide is the ability to work with the data interactively. So when you, in a typical development process, you write the code, you test it with some local data, then you put it in, you build it, you put it in your UAT environment, and then you test it with the real data. This is not the way SQL developer has been used to do it, actually. So we need to give them a way to test their job interactively. So we basically gather all these requirements, and we came up with an internal product, which is called, this name came from was a funny name that came up, and then we just kept using it, which is called Sparkola, that basically tries to mimic the behavior of user-friendly tool like Oracle Studio, Teradata Studio, but on top of the big data world. So some of the key features. It offers a web-based UI, so users can interact with the data directly from the UI, which interfaces to a Spark-based backend. It's packed with a stack that is specifically optimized for SQL and for people who have been using SQL. For example, you will find a lot of delete statement and update statements in your legacy SQL. It's not so trivial to replicate those operations in the big data world. So that's why we said, let's find a way to enable this. So we started evaluating different technologies that allows us to mimic as much as we can the behavior of an RDBMS. Automated deployment mechanisms. So as I was saying, we don't want the user to go through the entire process of CI/CD, deploying, testing, etc. Everything should be taken care. So from the UI, the user can directly build a job and deploy the job. Another very important aspect, especially for us, is lineage capturing. We wanted to leverage the Spark to automatically capture the lineage. So that's what we did. So we basically analyze all the job that the user produces, and we automatically capture the lineage. Later, Chandra will show you more in detail about this. And the other thing is that we wanted to bring the test-driven development approach into the data pipeline development. So the tool also allows to write tests against the data. This is a quick, very brief overview about how the bank used to do. The bank used to basically create jobs and deploy jobs. So we're going through. Usually, there were a set of requirements that were specified by business. Out of those requirements, a mapping table mapping the source to the target were built, and based on those specifications, compute jobs were actually built, which are a SQL procedure, were built, and after that, all the testing was done. We kind of reversed the approach a little bit. So basically, we start from the development first. So we allow the developers directly to build the transformation directly in the UI. In the UI, people can build their test. People write their SQL, and the lineage is automatically extracted, actually. So all the process of defining the requirement, defining the source-to-target mappings that are needed for lineage capturing are not needed anymore because we can capture the lineage automatically. So this is basically the process of how a job is produced. The user goes to the UI, start building the job, start building the test. He's able to test the job with the real data directly. And once he's happy with that, basically he can, with a click of a button, just deploy the job, which is basically packaged in a form of an artifact. And then at that point, that artifact, which is immutable, can be promoted to different environments, because as you can imagine, we have UAT environment and you have production environment that are completely isolated. So this gives you a little bit of an overview of what we've been trying to build and what we are still building. And now I want to hand over to Chandra, which he will give you a more in-depth overview and maybe a demo of what we have done. Thanks.
Okay, so I'm going to take you through all the our tool Sparkola basically, and how a job can get developed on top of it, and how the job anatomy looks like, and how the core part of it is there. And I'll give you a brief overview of the architecture and the key features. So we have two modes. One is the interactive, and another one is batch mode. In interactive mode, you will do an analyze, code, build, and validate. In the batch mode, you basically like configure, prepare, and schedule and execute. So there is a step in between those two. So basically, we do the build. So the build is an immutable. When you do the build for the job, it's an immutable artifact, and we store it in a Nexus repository, and it can be deployed across the environments. So basically, it involves like packaging, storing, versioning, and promoting, right? So this is our kind of modes that I can describe, and I'm going to take you through the job anatomy, right? So a job requires a job definition, and a job requires some set of arguments where you can configure those arguments, and the job has a set of pipelines. So we support like 3 different kinds of flavors. So one is like SQL, Scala, and a rules-based pipeline. So in order for a pipeline to execute, you need to access your data sets. Your data sets could vary into different parts, right? So one is like inputs, outputs, and you also have arguments for these data sets. And we also have custom functions that we can import into our pipelines. So like UDFs, UDAFs, or any other functions. And so as a part of the pipeline or SQL or Scala, you can access this UDF in your job. So and the one is like the metadata. So this entire journey is driven by metadata. So if an entry is not there in the metadata, so we don't even start the job, or we don't even do the development. So metadata capturing is most important for us, even for pipelines, inputs, outputs, everything. So this is the typical job anatomy that I can bring in. So next is so this is the introduction to the tool, right? So we have editors. So one is the job editor. The job editor shows things like inputs, outputs, functions, pipelines, and tests. So you basically can select any kind of data set and choose your type. So this is some sample example, like you can choose your data set, and basically you can visualize the same, what does a data set consist of, right? So, and you also have a filter push down kind of thing. You can filter out initially, like you can choose a specific partition, or you can supply a query on top of this input data selection itself, and actually pre-filter the data. So this is all about the input editor. You can choose multiple inputs as a part of your pipeline and run your job. So So the next one is the output. So it's like multiple sources to target. So that's how it is. So in a compute side of the world, so basically what you do is you pick and choose multiple tables, and you arrive at one single target table where you want to showcase in your report, or how do you want to use them in your dashboards. So this is output. And the next one is the functions. So functions, I must say that we have implemented some very good libraries that the actual RDBMS has. So like date libraries, calendar libraries, string libraries. There are lots of libraries that we have started implementing, and those are all available in the product. So we were talking all about metadata driven. So what does metadata driven means? So typically when you choose a file, it can be CSV, and since we are bank, we have mainframe files. We have lots of XML files that come from the message queues, and we have JSON that comes from the open, like outside web, and we have lots of RDBMS databases, right? So everything will have its own metadata. So how we are going to govern this metadata? So basically, we came up with a solution called Enterprise Metadata Management. So everything goes, any data set that you have in the bank, so goes to this Enterprise Metadata Management. So how we adopted this Enterprise Metadata Management as a part of SparkCola is basically we have something called catalogs. So catalogs is a way how you choose your data sets. So we can choose our data sets from Enterprise Metadata Management, and we can choose from Hive, and we have some other, we can choose from Teradata or Oracle, or using their metadata queries, so we can actually pull the data sets from them. So this is a way how you can mix and match data between different metadata catalogs and pull those data sets into your pipelines. So this tool allows us to automatically write different catalogs whenever we require, if our data sets are there. So the next part is like, okay, I have to talk about schema evolution, because so in a continuous process, right? So when people are developing their models, like what I mean is like a data model or a logical data model. So things are gonna change. So you might be adding new columns. So you will be adding new data types. Data types keeps changing sometimes, right? So how you have to support all of these. So a thought process has to be kept, to adopt these kind of schema changes that happens continuously. So what we did was we wrote a Hive integration library, Hive Metastore integration library, and integrated with our Enterprise Metadata Management. So any changes that happens in the Enterprise Metadata Management, so it will automatically reflect back into the Hive Metastore after some approval process and all those things, because it's a bank. So we also capture the drift. So how the column or the table or the data set has been changed across the time. So the drift is captured as a part of our schema evolution. So this concludes the process section, and now I'm going to show you the architecture. So the actual, if you have heard about our yesterday's talk, so we have presented like how to write interactive and applications on top of Apache Spark. So this is like a gist of it. So basically, what we have here is we have a container. Yarn container is the whole underlying provision. Is the whole underlying component for us, and we can provision the Yarn the containers for us. And we have session provider where we actually go and configure our session. So we can give a Spark session to the actual project or the tenant that when launched, and we have tight integration with the key tab and vaults. And we have authentication with LDAP. So this is the typical architecture, like how we actually run our application, our interactive application. Next is the component architecture. So we have multiple layers here. So one is a data and metadata layer. The other one is a data access layer, which is all driven by contracts. And the other one is the components layer. So the components layer is where we use specific SparkSQL libraries and custom functions, UDFs and UDAFs, all those stuff. So, and everything is powered by Beanzoo. Beanzoo is our open source library where we can actually invoke services and actually use multiple containers and do an exchange of the objects itself. So So we have the metadata layer is the high meta store and as well as enterprise metadata management. And we support like 3 different formats, like Parquet and CarbonData and Arrow. I'm going to introduce you to the CarbonData, like people who have already heard about it. So it's good, but I can actually briefly talk about it as well. So we use Hive and HBase, and our underlying cache is Alluxio, and deep down it's S3 object store. So coming to the core part. So the core part is having GUI and Spark for SQL, Scala and rules, and plans and lineage. And I'm going to show you the SQL stack as well. So as I said, we have 3 kinds of editors. So one is the rules-based editor, SQL-based, and Scala-based. So it's just a simple SQL that I am showing you here. So you can write a SQL inside the editor itself directly. And next, this is the Scala-based thing. So in the Scala-based, basically, you can embed your Scala code directly in your pipeline. So all you need is to implement these 2 methods. So because we actually drive lineage along with the code, so that's the reason why you see the lineage. And another one is the actual process where you need to execute the business logic. So that's the process and get lineage methods there. So the next one is the rules-based pipeline. See, rules-based pipeline is our guided IntelliSense way of writing the business logic. So typically, it exposes all the Spark functionality using Java processors. So we have written our processors in Java, so they can be automatically pluggable in the UI, and you will see all the things like filters, union, conditions, binary expressions, all those stuff, expression evaluation, everything. You can actually do it in a rules-based way. So I can show you a demo, probably if time permits later. So what happens when we work like this? What happens in the background, right? So we have something called source code that we generate. So this source code is purely in YAML. So whatever we configure or write in our editors directly goes into this YAML automatically, and then it is connected to the version control. So we use Git as version control. So any new jobs that you develop, any new things that you do, so directly goes into the Git as a Git version control. Right. So next is how did we do an optimized SQL stack? So I must talk about CarbonData here. So we use Carbon is an I think it's developed by Huawei, but it is open sourced. It's called Apache CarbonData. So it's a file format basically. So it supports, if you use CarbonData, it supports updates, deletes, and every new run is a segment in there. So basically, it does indexing. You can have multi-dimensional key index, and also it supports local and global dictionaries the same way as Pocket support. But it adds indexes as an extra booster, and it supports updates and deletes. So what we are using as a part of Carbon is update. So update happens like a dictionary as a dictionary append, and there is a new index will be added, and every time whatever records you're changing, there's a bitmap file that will be created for delete, and delta and regular data will be inserted data. So this is how it is created. And there's a delete as well. So delete is basically you don't change anything in the dictionary, but you mark the rows, the deleted rows in the bitmap file as deleted. That's it. So there is no change in the indexes. So it has got lots of other things like compaction, automatic compaction, major and minor compactions, a lot of things it handles. But this presentation doesn't tell you all about that scope. But yeah, so we have the SparkSQL on the other side where whatever supports as a part of Spark, so we use it. Any other extra things, we write custom UDFs. So here now we are also looking into implementing some custom parsers for different other for different constructs. So we are experimenting with that right now. Okay, so this is the typical SQL stack that we use, but apart from SQL stack, we still have Scala editor as well as rules-based editor. So when there is a feature request that comes for us, so we actually develop those things in our bank. So lineage extraction, this is one of my favorite topics because so whatever code you write, so it has to have a traceability. So every column that you actually see, so it has to have a traceability, like where it came from and how it has been transformed and how it has been derived. So these are the various aspects that you need to consider as a part of regulatory purposes, so when you actually build a transformation logic. So Sparkola provides automatic extraction of lineage code and store it for regulatory purposes. And basically, we currently do only column-based lineage, but there are tools out there which does file-based lineage and all those things. But we felt for a developer, it's a column-based lineage is the most important thing, because he has to see where the data comes from or how the column is being transformed. So, okay, showing this is one of our SQL query that we have used, and you can see there is two sources and one target, and in between it is doing a union, and there are some filtering that has happened. So from the picture itself, you can tell what is the query looks like. So so you can actually do a traceability here. So you can pick a column and see how it has been transformed. But so the actual, you can actually later in the demo, I'm going to show you like how you can actually get this graph. So you can actually pick a column and see, okay, it has been union, it has been selected, it has been alias, and it has been filtered. So in the filter, basically what sort of filter condition has been applied. So all those things you can directly see in the lineage extraction. Yeah, as I'm talking about custom functions, right? So there are library functions. What we have done is like we have taken the grammar for date library functions and calendar library functions, and we have identified all those things, and we have implemented the UDFs for that. Okay, so and we are actually there is one typical problem, like how do you do a hierarchical query in Spark? Okay, so we wrote some connect by prior or connect by clause kind of expressions using in Spark, and also like you have something called qualify clause that will be used in different RDBMS, where you need to do a selected qualify of records. Yeah. So this is how it looks like. So this is typical example of our UDF libraries, and the last one is the launchers and the job server. So we have like three types of launchers, like a Spark launcher and a Yarn launcher, and you can bring your own jar, and we'll launch for it. So that's what, because since we are a data platform in the bank, so we have to adopt this kind of mechanism. So our job server typically looks like this. So we have job instances, job definitions, job runs, and we actually connect to the launchers, either Spark or Yarn, and then promote the job to the job server. So why did we do a separate job server is because, so we want to customize our own launcher, and we can't use an external open source job server because, since we want to customize our own launcher, so we wrote our own job server. So this is how we track jobs and job instances. So they have two parts, right? Three parts: job definition, job instance, and job status. So this is the details, and you can import and export job instances. And you can see all the Spark, whatever the Spark UI gives you. So all are present in this job status. So actually, this kind of concludes the presentation. I'm going to give you do we have still time? Okay. All right. So I'm going to open the floor for the questions.
Any questions? Or do you want to do the demo?
Just do the demo,
okay.
A short demo. So you can see here the job. You can actually create a new job here like this, but I have already created a demo job here. So when I open this job, basically you have inputs, outputs, functions, pipelines, and tests. So in the inputs, so basically you can actually see the data like this. And you have an output here, and you have different sort of pipelines. So in the pipelines, you have rules-based, SQL-based, and ScalaBased, and you can write your SQL code, and you can see the lineage, and you can see the results, pipeline by pipeline, actually. So, and you have tests here, so where you can do your validation. So this is running on my local machine. So there is lastly a composer. This is a rules-based pipeline, where you can say, okay, I want to load my entire DAG, and I want to store my results back into the sink. So this is how I can actually do it. So let me run the lineage for you. So this is a pretty big query, right? So the lineage actually goes and traverses across. So I mean, to a naked eye, we can't find anything from it. But if you see a column traceability, and we also have a simplified graph that can bring from source, how the source is being mapped to our targets. So typically, if you expand this, you will be able to see. So here you see like so there is a filter being applied, a sum, and there's a union that's happening here. There is some sort of aggregations here. Date format functions has been there. So there are various things that actually that it does. So you can see a long filter here right now. So this can be simplified. This is already simplified for us. And when we actually commit to our enterprise metadata management, so basically as a metadata, so this lineage actually goes there. So let me click the results here. So other interesting thing is you can use it in arguments. So different varying arguments here, and you can test your job with different country code, business date, or like different parameters that you want to use. And it's a little big. Data is pretty little big, so let's wait for it. And this is the source code that you can see, and these are the arguments that you can configure actually. So your arguments can be different types of things like date, string, all different data types you can specify here. Okay, so the job has completed, and you can see the results here. So there are like 11 records that came out of this, and you have this validation that you can do, the test. So we can actually create validators here, like row-based validation, column-based validation, like a hash code, row hash code validation, that sort of things that we can do. So, but I think the data, whatever we are comparing is, it has 22 records. The results will fail actually here because the data sets doesn't match. Typically in migration-based projects, what happens is like these sort of things, because you have to compare with your reference data set and you have to validate it. So that's why these kind of validations will definitely help us. All right, by the time this completes, any questions? Yes, sure.
Hey, thank you for the presentation. I think the lineage information definitely useful for no matter understand the logic and do the debugging. I suppose you do that by syntax tree, right?
Yeah.
Just wondering. But just one curious question about what if a table or any kind of column depends on B and B depends on A again, which is a closed loop dependency. How do you guys actually resolve a problem like that?
Yeah, answer.
No, we actually we extract the lineage not from the syntax tree, but we extract it from the Spark logical plan, actually.
It's the partial logical plan that
yes,
we use.
Yes, the Spark logical plan. And in loops, actually, so we detect the loops, and you would actually see the loops in the lineage graph, actually. So the graph will contain itself a loop, actually, and you will be able to see it in that.
We actually use a iGraph library, so it's.
So basically, what happens is we have an in-memory graph for the lineage, but this graph actually basically is used to this subgraph is later on posted to the entire enterprise lineage graph of the entire bank. So this job contribute to the bigger graph. So if you go to which is a graph database, if you go to the graph database, you have an overview all the way from the source system to the report that is being produced, even if this involves multiple jobs in different steps.
All right, thanks everyone, and thanks for the presentation. Please remember to rate the sessions afterwards, okay? Thanks.
Thank you.